Hello, this is Sigma Bob. In this video, I will be discussing problem 18 from the AMC 10 2025B. We will carefully examine the problem statement, identify the key idea required for its solution, and work through the steps in a clear and systematic way. Let's get started. Here is problem 18 from the AMC 10 2025B. What is the ones digit of the sum, the floor of root 1 plus the floor of root 2 plus the floor of root 3 all the way to the floor of root 2025? Here, the floor of x means the greatest integer less than or equal to x. This is a problem where we need to group numbers by intervals where the floor of the square root stays constant, rewrite the sum as block contributions, and compute the total modulo 10 using repeating patterns. Pause the video here if you'd like time to solve the problem yourself. Now let's go through the solution. The key idea is that the value of the floor of square root n stays constant between consecutive perfect squares. Specifically, from 1 squared to 2 squared minus 1, the value is 1. From 2 squared to 3 squared minus 1, the value is 2. And in general, from k squared to k plus 1 squared minus 1, the value is k. So we rewrite the sum by grouping terms. For each k, the value k appears exactly in the interval from k squared to k plus 1 squared minus 1, which contains 2k plus 1 integers. That means the total sum becomes 1 times 3 plus 2 times 5 plus 3 times 7 plus all the way to 44 times 89 plus 45. Now we only care about the ones digit, so we track everything modulo 10. Looking at the product, the ones digits repeat in a pattern. 1 times 3 gives 3, 2 times 5 gives 0, 3 times 7 gives 1, 4 times 9 gives 6, 5 times 11 gives 5, 6 times 13 gives 8, 7 times 15 gives 5, 8 times 17 gives 6, 9 times 19 gives 1, and 10 times 21 gives 0. This pattern repeats every 10 terms, so we compute the sum of one full block. The first 10 terms have a ones-digit sum of 5 modulo 10. There are 4 full blocks from 1 to 40, contributing 4 times 5 equate to 0 modulo 10. After that, the remaining partial block contributes 0 as well, and the final leftover term as 45, which contributes 5 to the ones digit. So the final ones digit of the entire sum is 5. The final answer choice is D, 5.